All right, also one more skill for this, which is scale factors. So scale factor is the rate by which the sides of a shape scale up to get from the first version to another version. I keep wanting to say smaller and bigger. It's not always smaller and bigger, but when we have a number like 5 that's not a fraction less than 1, it's going to be getting bigger. If it's a fraction less than 1, the scale is smaller. In this case, it's plenty big, so it's going to be getting 5 times bigger. Scale factor means how many times bigger it's going to get. So that means the length and the width are both getting 5 times bigger. This is going to be multiplying by 5, and this is going to be multiplying by 5. So 4 times 5 is 20, 2 times 5 is 10. Now, we can use it to talk about areas too. The area of this original small rectangle is 8. The area of this new one is going to be 200, and that'll be units squared versus the same units squared. But here's this really weird conundrum. You notice 200 is not 5 times bigger than 8. 8 times 5 does not equal 200. But why? Confused face. Now, here's the reason why. When you took that length times width to get the area, right? And you took the second length times width to find the new area. Let's call that area 2. Let's call this area 1. And you multiplied these by 5. That means you're essentially multiplying the areas times 25 because you're doing a length times a width. So let's check that. Is 8 times 25 equal to 200? 25. Let's do 25. 25, 50, 75, 100, 125, 150, 125, 200. Yes, that checks out. So these scale factors only apply to one-dimensional sides, length, width, height, etc. The area or the volume, you're going to need to get a little thought deep on it to make sure you know what you're doing before you try to convert areas to areas. I would highly recommend just doing the side lengths. Length scales up, width scales up. Another example, let's just try it. Let's say the scale factor is now 2.5. Let's say it was, 6 versus 4. That means this is going times 2.5. This is going times 2.5. I'm looking for the area of the new shape. So 6 times 2.5 should be 15 units. 4 times 2.5 should be 10 units. 15 times 10 should be 150 square units. Cool. Now, if the scale factor is a fraction, let's say 1/2, what that essentially means is that the shapes are getting smaller, not bigger. I said before about how the scale factor is less than 1 means the shape's getting smaller. This means that the second shape is 1/2 the size of the bigger shape. So let's say this was 8 and this was 6, right? The scale factor is 1/2, means I'm multiplying by 1/2 for each individual side. 8 times 1/2 is 4. 6 times 1/2 is 3. The area of this new one is 12. The area of the old one is 48. And want to know scale factor? Scale factor times itself times scale factor for length times width is 1/4. 12 is 1/4 of 48. So that does check out that way as well. Cool. If you have any questions, just let me know.